Hello everyone, welcome to today's webinar. We're still working on the Algebra 1 course. We are still working also on Unit 4, Exponents and Roots. Today we will look at roots. We're going to look at the basics of operations with roots. We're going to add, subtract, and simplify radical expressions. This is myself. My name is Mariam. I'm a math instructor at Penn Foster here. I am certified to teach high school math in the state of Pennsylvania, and I have my master's degree in education. I'm happy to walk you through this section of Unit 4. Roots are not a topic that everyone is familiar to, so maybe the rules for adding, subtracting, simplifying roots, and later on multiplying, dividing, rationalizing, everything now maybe is going to start to seem it's new to most of you. So I hope by the end of the webinar, we're able to summarize the rules, practice, and do some work together so you feel more convenient working in this section of the unit. Today's webinar, we're going to cover the most challenging topic in the middle section of Unit 4, which is the basics of roots. The self-check questions that you're going to see throughout the webinar are not required, are not graded. They are just included in this webinar to give you a chance to assess yourself and see if you need help in a certain topics in that section of the unit, or if you're fine, you're ready for the exam in that section. If you have questions, I'll be happy to answer them if they are relevant to what we speak about during this webinar. You can type your questions in the questions box. The raise your hand feature does not work during our webinars. So the only way that you're able to communicate your questions is to type in the questions in the questions box. All registrants for this webinar, attendees and absentees, will receive a recording of the webinar to watch at their convenience. So, as I said in the beginning, today we will look at how can we simplify a radical expression, or simply we just call them radicals. Add, subtract radicals. Multiply and divide, that would be on the next webinar, so make sure that you sign up for the last session of this webinar series on Unit 4. So we're still gonna add, subtract, simplify. Next webinar, we're gonna do multiply, divide, rationalize denominators of fractions of radicals, and then later on in the next webinar, we're gonna cover how to solve radical equations. So please sign up for the next webinar, so both of them, they will integrate each other's and you're able to work through this part of the unit more conveniently and more confidently. Now, I need to go over some basics of roots. And before we do that, we need to understand what is a root. So we learned from last webinar that if you have a number, you raise that number to an exponent, we knew what does that mean. So for example, if you have the number 2, for example, and you just wanted to raise that 2 to the third power, we understood that that means it does not mean 2 times 3, but it means that 2 times 2 times 2, 2 times itself 3 times. So this is what powers mean. What about roots? What does roots mean, or taking the root of a number? Well, the root is the opposite operation of raising a number to an exponent. So in this chart that you see here, I have red numbers and black numbers here. We're going to use the red numbers, the red list of numbers there along the rest of the unit. So we need to keep these red numbers handy. I'm going to explain why. So how come then roots, or taking the square root or any root of a number, is the opposite of raising the number to an exponent? So let's see, if I'm going to start with a 1 and raise the 1 to the second power, for example. So 1 squared is 1. Take the square root of 1, it will give you back the 1. Well, 1 is a special number. So let's look at 3, for example. 3 squared will give you 9. The opposite is taking the square root of 9 will give you back the 3. So when you take the square root of 9, you go back to the original 3. So this is how we think of taking the root of a number as the opposite of operation of raising the number to the exponent. Now, are all roots square roots? And the answer is no, but the common roots that we will be using in our unit and later on in our geometry class, if you're gonna take that geometry class, is the square root. That's the standard one that we always use in formulas. I mean, unless the formula says otherwise, but the most common one is the square root. Now, what if I have 2 raised to the 1 over 2 power, raised to the half power? That is the same as taking the square root of that number. So remember, that is one rule that we need to make sure that we understand. When we raise a number to a fraction exponent, actually we are taking the root of that number. And those rules I have on the side of the screen here, they will summarize those rules I'm going to speak about. So if you raise a number to a 1 over x exponent, 1 over 3, 1 over 4, 1 over 6, you are actually taking the root of that number. So another example, if you take the third power of 27, so raise 27 to the 1 over 3 power, the third. So 1 over 3 power, that means you're taking the cube root of 27. So you should be clear on what fractional exponents mean. They mean roots. And those rules will teach you how to rewrite a fractional exponent in terms of roots. So if you have a fraction like 3 over 5 that is the power of 14, we actually is able to represent 14 raised to the 3/5 power as 14 raised to the third power, and then you're taking the fifth root of that number. So this is how we represent that. The 5, which is in the denominator of the power, will be the degree of the root. 3, which is the numerator of the power, will be actually the power raised for that number under the square root sign. We do not have to evaluate those expressions. For example, the square root of 2 is 1.41421356. We are not going to be able to use that huge decimal number in our calculation, so we just stick with the square root of 2. The same thing if you are asked to find 14 raised to the 3/5 power, you don't have to use your calculator to know the exact value of that. This will be your end answer. This will be your final answer. If you have any questions, if you just joined us, you can type in your questions in the questions box. So far we understood that roots are actually opposite operations of raising the number to an exponent. Now, those red list of numbers we need to keep handy, either on your notebook, you keep it handy on your notes. If you're printing out the study units, you can write them everywhere on the margin of these lessons that speak about roots. Those red numbers, we call them perfect squares. 1 is a perfect square because when you take the square root of 1, you have a whole number back, which is 1. 16 is a perfect square because if you take the square root of 16, you end up with a whole number 4. Now, 2 is not a perfect square because if you take the square root of 2, you will end up with a decimal answer. Those list of numbers, those list of perfect squares, we will use a lot when we simplify radical expressions or radicals. Any questions? Anything that was not clear? Well, the next question is a self-check. Again, those self-checks are not graded. They are not part of your grade for the final overall grade for this course. It's for you just to see how would you do the question if that question was in your exam. How would you do it? So simplify the following radical expression or radical. 13 raised to the 10th over 23rd power. So the power is here a fraction. And we'll just learned when you have a fraction in the power, it means what? How would you represent that in terms of radicals? So for those questions that you're going to see during my webinars, I'm going to keep the question on the screen for about 40 seconds, and then I'm gonna switch my screen to where you're able to actually input your answers. Now, the answers were not going to be spelled out like the ones that you see here, because it is hard for the software I'm using to type in the square root signs and the exponent sign properly. So I'm just going to have A, B, C, D as the choices, and then you're able just to choose the letter of the answer. So you can start working on that question, and then in a few seconds, I'm going to switch my screen, and please participate on those questions. It tells me a lot about how I teach, and also it tells you how you're doing so far in that unit. So take your time and do the question. Okay, I'm going to now display the same question with only the letters of the answers, and which one you think is the right representation of the expression here. And here you go. Okay, I would like to share my answer for those questions, so when you get the recording, you can actually pause the video and work on those questions on your own one more time and figure out why you did or did not get the same answer. So the right answer for this question is actually B. B. Remember, if we have a fraction in the power, the numerator will become the exponent, and the denominator will become the degree of the root. So this is how we write this expression using radicals. Okay, so let's then learn how to simplify a radical expression or a radical. Now, the first question is the square root of 24. Now, the first question that may come to your mind is like, how can I simplify that? 24 is just the square root of 24. What should I do more to make it in simplest form? Our job our job is to break down this number under the square root, in this case 24, and try to see if any of the factors of 24 are perfect squares. And that's why I've brought up the list of the red numbers, the list of the perfect squares with us here on the screen, so we can make use of them and decide if 24 has at least one perfect square factor or no. Now, the next question that you may have in mind, how can we know? How can we decide that 24 has at least one perfect square factor? The way I do it is to just go by order, or just use my knowledge for the multiplication table. Now, I know that 4 is a perfect square, and I know that 4 also is a factor of 24. 4 times 6 will give you 24. So actually, I am able to break down the 24 under the square root sign as 4 times 6. So I did not change anything under the square root sign. I just broke up the 24 into 4 and times 6. That will give me back the 24. Now, why did I do that? Remember those red list of numbers, they are perfect squares, meaning that if you take the square root of 4, it will give you a whole number, 2. So I'm using that to simplify my radical. Now, the rule that you see here on the top gives you a way that you're able to apply the square root sign to the 4 and to the 6. It says if you have two expressions, two letters, two variables, two numbers multiplied under the square root sign, you actually can distribute the square root sign over each of them. So that is equivalent to the square root of 4 times the square root of 6. Now the square root of 4, I know that it's 2. Now the square root of 6, if I think about the factors of 6, they are only 1 and 6, 2 and 3. None of those 4 factors are perfect squares. Then 6 under the square root sign is in simplest form. I cannot change it to anything else, so it's going to stay like that. So our final answer is 2 times the square root of 6. That's the simplest form of this radical. Any question? Let's proceed to the next one. We have a bigger number under the square root sign, and most of us, we cannot think of the multiplication table that has a 98 on it. So what should we do in that case? Again, what I should do, or what I would do, is go by order. Try the 4. Divide 98 over 4. Divide 98 divided by 4, because I'm trying to see if 4, which is a perfect square, is a factor of 98. If 4 is a factor of 98, then the answer of that division, 98 over 4, should give me a whole number. If not, if 4 is not a perfect square factor of 98, then it should give me a decimal. I'm going to ignore the 4 and then go to the next one in line 9 and try that until I am able to reach a factor that is a perfect square factor of 98, if any. So I divided 98 over 4. It gave me a decimal, 24.5. So I'm just going to ignore the 4. Go down the list, 9. 98 over 9 will give you 10.888, which is not what I'm looking for. Ignore the 9. Go down the list, 16. Try 16. 98 over 16 will give you 6.125, not the one I'm looking for. 98 divided by 25 will give you 3.92, not the one I'm looking for. Let's try 36. 98 over 36. Decimal answer, ignore it, 49. So 98 divided by 49 will give you 2. Now I know that 49 is a perfect square, and it is a perfect square factor of 98 because when I did the division, it gave me a whole number, 2. Then I can go ahead and break down the 98 to 49 times 2. From the rule here, I can simply distribute the square root sign over each of the factors. And since 49 is a perfect square, the square root of 49 is 7. 2 is only having 2 and 1. None of them are perfect square factors, then should stay under the square root sign. Our final answer is 7 times the square root of 2. We pronounce that as 7 the square root of 2. That's it. Okay, let's do 3. Another big number that we cannot think of the multiplication table that would lead us to the factors of 72. I'm going to do the trial and error method that I've been using in question 2. So I'm going to start. I'm pretty sure that 72 is not a multiple. It's not something that 4 would be the factor of. So I'm going to ignore 4. I'm not sure about 9. Let's try 9. Maybe it is one of them. So 72 over 9. 8. Actually, 8 is the answer. Then that tells me that 9 and 8 are factors of 72. Then I can break this square root sign, or the numbers under that, to 9 times 8 equals 2. I know 9 is a perfect square because that's why I went ahead and tried that list, times 8. The square root of 9 is 3. The square root of 8. Well, 8 has a factor that I know of is a perfect square factor, 4. 4 times 2 will give me the 8. So I need to simplify further. This is not the simplest form. Well, 3, the square root of 8 is equivalent to the square root of 72, but 3, the square root of 8 is not in the simplest form, equals to 3, the square root of 4 times 2. Apply the rule here. So that would be 3 times the square root of 4 times the square root of 2 equals to 3 times 2, because the square root of 4 is 2 times 3. That's why I have 3 times 2, the square root of 2. Simplify further, multiply. 3 times 2 will give you 6, the square root of 2. This is the simplest form of this radical. One last example, the square root of 37. You can go ahead and try the list. I've tried it before. You will realize that there is no perfect square factor for 37. There are factors for 37, but none of them is a perfect square factor, even though the number is a big number. So it will stay under the square root sign as is. This is the simplest form that we can get. And that's it. Any questions on the examples that we have gone through together? Anything that was not clear in the steps that we did, especially the ones that we have used the list of the perfect square factors here? Okay, let's move on to a self-check. Simplify the square root of 80. What would be the simplest form of the square root of 80? I need to think of the list. 4, 9, 16, 25, 36. Which one is possibly, if any, is a perfect square for that? I'm gonna keep quiet and let you think about that and then switch my screen in about 30 seconds. Okay, I'm gonna switch and give you the answer choices to share your answers, please. Okay, and the final answer, the simplest form, the correct simplest form for the square root of 8 is D. If any of those questions, the self-check questions, if you want me to go over the specifics of how we got to that answer, you can type in the question box and just mention something like, can you go back and do the last self-check, so I can go back and do that for you. Okay, let's go to the next topic. What if we have variables under the square root sign? What would be the rules for simplifying those variables or that radical expression with variables? Now, with variables raised to exponents, we have some other rules. The rule says if you have a variable raised to an even number as a power, which is 6 here in this case, all you need to do to simplify is divide the exponent over 2. 6 divided by 2 is 3. Then the simplest form of the square root of k raised to the 6th power is k to the 3rd power. Why? Why do we divide the power over 2? We need to learn why. So when we are applying the rules, it makes sense to us. Now remember that when you raise a variable, a number, to the half power, 1 over 2 power, it is the same as taking the square root sign of k. Okay, what if my k is already raised to the 6th power, and that square root sign I can rewrite it as to the half power, 1 over 2 power. In the first webinar of this unit, we learned that if you have a variable raised to a power and then raised to another outer power, you multiply the powers. 6 times half is the same as 6 divided by 2, and that's why the answer is 3. So one more time, if you have a variable with an even power, and you're trying to take the square root of that variable, divide the power over 2, and that would be your answer. Now, what if the power is an odd number like 7? What should we do? Of course, we're not going to divide 7 over 2. You're going to get a weird power, like a fractional power, which is not easy to understand. In this case, we will break down the variable under the square root sign as follows. Well, m to the 6th power times m to the 1st power is actually equivalent to m to the 7th power. Remember, again, in webinar 1, when we used to multiply same variables raised to different powers, we used to add the powers. 6 and 1 will give you back the 7, which is the power here in our question. So when I break down my variable that has an odd number, I'm going to have an even exponent and an odd exponent. From the rule of radicals, when you have two elements multiplied under the square root sign, I can distribute the sign over each one. So I'm going to take the square root of m to the 6th power, the square root of m to the 1st power, equals to, that's an even power, divide over 2, then that would be m to the 3rd times the square root of m, and that would be your final answer. Nothing can be simplified further. Questions? Okay, let's do more advanced questions on that topic when you have variables under the square root signs with odd and even powers. What should we do? So first of all, I'm looking at 3 here, the square root of x to the 16th power times y to the 21st power. I know that 16 is an even number, so I have no problem with that. So I'm going to take the half of 16, which is 8. So x to the 8th will take care of the square root of x to the 16th power. Now I have the y to the 21st power with an odd exponent. What should I do? I'm going to break it down as follows. The square root of y to the 20th power times y to the 1st power. 1 and 20 is 21. So my answer would be x to the 8th times y to the 10th, because 20 over 2 is 10, and then the square root of y will just stay as is. One more question. If I have a factor and a bunch of variables raised to powers under my square root sign, what should I do? Well, the same thing that we have done in the past with numbers. Now I can think of this problem as the square root of 81, the square root of m to the 10th power, the square root of n to the 22nd power. Now the square root of 81, I know 81 is a perfect square. The square root of 81 is 9. What about m to the 10th? 10 is an even number, divide over 2. So that would be m to the 5th. What about n to the 22nd? Even number, divide over 2. N to the 11th power. That's it. Your answer does not have to have a radical sign. If you have to do it, then if you have to have a radical sign, then write it out. If not, then your answer is correct if you have followed the right steps to get to the answer. Number 5, 58 times p to the 11th power times q to the second power. So 58 is not a perfect square. And if you look further and you test with the perfect square list here, you will find that 58 does not have any perfect square factors. So 58 have to stay under the square root sign. What about the variables? I have odd and even. So my answer is I'm going to have the square root of 58. I'm sure of that. P to the 11th. Break this down to p to the 10th times p, and then q to the second, that's an even number, divide over 2, q to the first, so that would be in front of the square root sign. Let's simplify further. So we're going to have 58 staying under the square root sign, and p to the first will stay under the square root sign. What's going to be outside is the q and the p to the fifth, because 10 over 2 is 5. And that is the simplest form of this radical. Questions? Okay, let's move on to a self-check. It looks scary. It looks that we have numbers, powers, variables, a square root sign. If you're going to think about how the problem looks like, you're going to panic yourself. Don't think about how the problem looks ugly or overwhelming. Think about the rules. What are the rules that we have learned that we are able to apply to simplify that huge square root expression? I'm going to leave that as usual and then switch my screen. Okay, give you extra time because that question is a little bit challenging. And here is the other screen where you can input your answers. Okay, let's then look at the final answer. If you want me to do this question, let me know. Otherwise, I'm going to go ahead to the next slide. And the correct answer is C. C is the correct answer. And from that question, you see that 48 had a or has a perfect square factor, and that's why we do not see it under the square root sign in our answer. Okay, let's look at how to add and subtract radicals. Okay, so far we learned how to simplify just one radical expression. Now we have two expressions that we need to either add or subtract. What are the rules and how can we apply them? Now, the first thing we have to keep in mind is that you are able to add only radicals that have the same exact radical part. So, radical part, I mean the square root of 7 and the square root of 7. They are exactly the same. Both are multiplied to whatever is that, 4, 5, a number, x, a variable, whatever that number before the radical part of the expression. I don't care about that. I care about the radical part. If it's identical, I can go ahead and add 5 and 4 and keep the square root of 7. 5 plus 4 is 9, the square root of 7. Do not add 7 plus 7 and put a square root of 14. So the answer that looks like 9, the square root of 14, is incorrect. That's the common mistake that students would do. They would add everything in that line. So only add the coefficients, the numbers, the variables that appear before each of the radical parts if the radical parts are identical. Remember when we did the first part, and I would imagine unit 2 as well, when we had 3x plus 2x. We said we have an x and x identical, then add the 3 and 2, it gave us 5x. We did not add x and x, we just kept the x the same. Same thing here. We're going to keep the radical part the same, square root of 7. Let's do another question, number 2. 3 the square root of 10 plus 4 the square root of 10 minus 2 the square root of 3. Okay, so just to begin with, I'm not going to add the 3 to those two because this is a square root of 3 by half 10 and 10 under the signs of each radical here. I'm going to go ahead and add 3 and 4. I'm not going to add the 10s. 3 and 4 is 7. The square root of 10 minus 2 the square root of 3. Can I simplify 10 more here under the square root sign? The square root of sign, is it in simplest form, or I can simplify it more? Well, the factors of 10 does not have any perfect squares. 1 and 10, 2 and 5, and 5 and 2, and that's it. So that is your final answer, although it seems like it is too big to be a final answer, but actually this is the simplest form. This is the final answer. We are not able to combine those two terms. Last question on the screen here. 4 the square root of 27 minus 15 the square root of 3. Now 27 and 3. From the first look of the question, you may see, well, this is the final answer. 27 and 3, they are not identical radical parts of the question, then that's the final answer. Well, we need to look further before we decide if this is the simplest form or not. Look at 27. 27 actually has a perfect square factor. Let's simplify 4 square root of 27 further. So 4 will stay outside. I'm simplifying whatever is here with the square root sign. 27 is 9 times 3. And I still have to subtract minus 15, the square root of 3. Well, the square root of 9 is 3. So I have 3 times 4 is 12, the square root of 3. So this 9 became a 3. Multiply that times 4, and I have 3 left over under the square root sign, minus 15, the square root of 3. Now I see that both terms have actually the identical parts of the radicals. Then we can subtract or add. We are able to. 12 minus 15 is negative 3, the square root of 3. Any questions? Okay, let's look at more complicated examples on adding and subtracting radicals. Negative 9 times x times y, negative 9 times the square root of x times y plus 3 the square root of x times y. This time, the radical parts of our expression have variables. Well, I'm going to apply the same rule. If the radical parts are identical, then I'm able to add or subtract. Let's check. Square root of xy, square root of xy, they are identical. Then just go ahead and add negative 9 plus 3. Negative 9 plus 3 will give you negative 6, the square root of xy. Okay, next. 2 the square root of 45z minus 7 the square root of 80z. Okay, now we're getting to where we have under the square root of sign, we have variables and we have numbers. We have to be careful whenever we see numbers. They may simplify if they have one or more perfect square factors. Let's see the 45. I know that 45 comes from 9 times 5, and I know that 9 is a perfect square. So to begin with, let's simplify 9 times 5z, and then minus 7. What about the 80? How can I rewrite the 80 so I can use one of the perfect square factors if possible? Well, 16 times 5 will give you 80. So 16 times 5, and I still have times z. Okay, let's simplify further. Equals to 2. Now, 9, the square root of 9 is 3. 3 times 2 is 6. So let's write 6 here. So again, the square root of 9 is 3. 3 times 2 is 6. The square root of 5z. And 5 is just square root of 5. We cannot simplify that further. Minus 7. And then times 4, because the square root of 16 is 4. 4 times 7 is 28. So let's make it short and write the 28. So it is 28. I'm done with the 16 here. So what I have left over is 5c. Now, after I simplified both expressions, I realized that both expressions here in simplest form have the same exact radical part. I am able to subtract. So subtract 6 minus 28 will give you negative 22, the square root of 5z. So the main point of those longer questions is to simplify first and then decide if we're able to perform the addition or subtraction or no. Let's do the huge one here, the last one on the screen. 3 times 16 x squared yz to the third plus 5 the square root of 16 x squared yz to the third. Now look at the square root or the radical parts. They are exactly the same. Then I am able to just go ahead and add 3 and 5. So add 3 and 5 is 8. And keep the same radical part because they are the same in both. 16 x squared yz to the third. Now I see that there are variables with exponents and I see a perfect square number under the square root sign. This is a correct answer but not in simplest form. So to simplify that, I'm going to take the square root of 16, which is 4. 4 times 8 will give you 32. Also, I have x squared. 2 is an even power. Divide over 2 will give you x to the first. And then y adjusted 1. Y to the first, I cannot simplify that further. So I'm going to write it as y. The z has a power that's odd. So I'm going to break this down as z squared times z. Simplify further. 32x, well, z squared, take the square root of that, will give you a z. And then what's going to remain under the square root sign is yz. So your answer is 32xz times the square root of yz. Any questions? Anything that was not clear or didn't match up with whatever you've read in your lessons if you're already done so? Okay, let's go to the next slide, and it is a self-check. 3 square root of 24ab minus square root of 96ab minus 3 the square root of 10a. How should I perform the operations with those three radicals? Take your time and try to find the right answer. Okay, I'm gonna give the list of the answers and you can input your answer. Okay, so the right answer for this question is actually A. A, and it makes sense because 3, the square root of 10a, cannot be combined with the ones that has an AB and AB. So for sure, our answer has to have like a radical with an A variable. So this one is not correct. And this one is not correct. And this one is not correct. So by elimination, we are able to say that this answer is the correct answer. If you want to do the exact math, I'm giving these steps because some of you are thinking about the SAT exam, the SAT exams, or the ACT exams. So in those exams, the timed exams that you have a multiple choice exams, questions on them, it is encouraged that you use the elimination method so you can get to your final answer quicker than just doing the literate math. But you're able to do the math and make sure that this is the right answer for the question. And that was it with my math part of the webinar. Today we learned how to simplify, add, and subtract radicals. Next webinar, as I said, will complete the Unit 4 with roots. Next session would be multiplying, dividing, rationalizing, and solving radical equations. So make sure please to sign up for this webinar if you are interested. How would you prepare for the exam? Of course, you want to study the unit, discover more questions or practice questions. Check your answers using the answer keys provided within your unit. Maybe watch that webinar one more time. Also, another outside resource I find helpful is khanacademy.org. If you go to their website, on the top left corner, you see subjects. Click on that. Choose Algebra 1 and choose the rational exponents and radicals. And under that, um, watch the videos and do the practice under simplifying square roots. That would be something optional. You don't have to do that, but some students have asked me about extra resources for each topic. How else you can get help? You can call, you can schedule an appointment with an instructor or a teacher assistant. You can use this link to schedule your appointments. That link actually will give you the option to schedule appointments with different courses, not only math. If you have a quick question that you have and you have the time to wait online over the phone or just wait for the email to be handled, you can text message that number and type in learn. That will get to the education department. If you type in coach, that would be your coach who can just assist you with general information with the program or lessons. And if you type in help, that would be a financial question to student services. How would you email an instructor if you have a detailed question and you want a detailed answer? Some of you have this kind of the account, some of you have that kind of the account. Follow the steps for the account that matches your account and you'll be able to send your instructor an email. Thank you for your attendance and please take the survey at the end of this session. The absentees as well are able to access the survey through a link that would be included in the follow-up email with the recording. I appreciate your feedback. It will help me to improve my webinars and to learn more on how I teach or how I should change things on my webinars. If you have questions or general questions, you can type in the questions box. I'll be happy to answer them before I end the session. Okay, then if you don't have questions right now, you still can text message, you can email, you can call if you want, or if you have a specific time that you want to speak to an instructor or a teacher assistant, you can schedule an appointment. Thank you for your attention and your attendance. Good luck in the exam.